I'm John Weaver. I'm the facility manager here, was involved in the initial vision and the design and construction of the facility, and then in operations once we were going. The Birck Center is designed based on a vision. Dick Schwartz and Jim Cooper put together a vision of what they really wanted in terms of a research facility that was dedicated to collaborative work and interdisciplinary work in both nanotechnology and microtechnology. We were able to design the building based on that vision rather than trying to fit something into an existing building. We involved faculty from a number of different departments who really looked at what their needs were, looked at where their needs were going to be 10 years out in the future. We're able to project some things there, and we were able to design the facility so that it would accommodate that vision and the needs that they foresaw happening in the future. Probably the most impressive of the laboratories outside the clean room is the Hall Nanometrology Laboratory. In there, we designed the room to control temperature, electromagnetic interference, and vibration. Those three are very important factors. Vibration is very important because things moving around when you're working on very precise measurements at the nanoscale will cause you problems. Temperature is important because things change size as they change temperature, and electromagnetic interference is important because we move things around by electric and magnetic fields, what we call nanotweezers, where we're actually moving individual atoms around. And if you have stray fields, that'll interfere with that. To conquer the vibration issues, we used a 30 metric ton slab. It's about 8 feet by 12 feet by 5 feet thick that's floated on 6 air pillows. This damps out all of the vibration that we would have coming through in there. We meet a NIST A1 vibration rating, which is the quietest in existence. For temperature control, we have a totally separate air handling system that just works for that laboratory. That air handling system then feeds into a room that has 2 thicknesses of wall that are R45 insulation property, kind of like a commercial freezer, and then a 12-inch air gap in between those walls. So that gives you extremely good insulation. With the control system, which is very carefully tuned in there, we're able to control temperatures to 0.01 degrees centigrade. So very, very precise temperature control. And finally, electromagnetic interference. We have 4 levels of metal in the walls. We have metal in the floor, metal in the ceiling, making a complete Faraday cage, which prevents any electromagnetic interference from getting into the room.
Well, the Cypher's Nanofabrication Laboratory is a state-of-the-art clean room. It's ultra clean. We have the capability of making devices and materials down to the nanoscale, which in our case we can make critical dimension feature sizes down to 6 nanometers across. What we do in the SNL, there's a very broad range of topics, and these are researchers from all the disciplines. They converge here to the Birck Nanotechnology Center and work in our clean room. And we have electrical engineering projects, we have mechanical engineering projects, physics, chemistry, biology. Some of the applications that we're working on are new MEMS devices, the micro-electromechanical systems that actually have micro-moving parts, and they can do sensing and actuation and different applications like that. We're working on a variety of technologies for cancer research, for targeted drug delivery, for specific aiming of radiation treatments, those types of things. We're working on new materials that have properties actually that don't exist in nature, and we're also working on a variety of other topics that gets into thermal characteristics, heat transfer, cooling of chips, ultra fast modern electronic device technology, just a broad array of projects here. We also have atomic layer deposition systems where we can layer multiple layers of sandwich type materials, 1 atomic layer at a time, and then these have some unique properties and characteristics used in various applications. We also have AFMs, or atomic force microscopes, that allow us to feel the surface of materials, and we can actually discern individual atoms with certain techniques in terms of how we measure those surfaces. Well, several features make us really unique. We have the largest clean room of any university in the country. We have 25,000 square feet of clean room. We have the cleanest clean room. We have about half of our floor space is called Class 1, which is the cleanest you can possibly make air in any environment. We have ultra-pure water, which we use in our processing, and it's the cleanest water on Earth. All the minerals, all the contaminants have been removed from it, and so it's actually the cleanest water that you can get. What we mean by Class 1 is if you take a cubic foot of air and measure the number of particles in it greater than a half micron in diameter, then Class 1 means there are one or fewer particles in that cubic foot. So we're uniquely the only clean room associated with a university in the country that has Class 1 capability, and about half of our floor space is considered Class 1. Most university clean rooms are Class 10, Class 100. So we're cleaner than any other facility. And what that allows us to do is to work at very, very small geometries, not have to worry about small particles interfering and causing devices not to work or materials to be contaminated because we have such clean air. Same holds true for the water as well. As part of the processing to build devices or materials, you need to do some interim steps with rinsing and cleaning the surfaces, and we use this ultra-pure water for that. And so if the water is totally contaminant-free, then we don't have to worry about contaminating our devices.
I am Kshitij. I go by KZ as well. So I'm a PhD candidate in Mechanical Engineering Department. Birck is home to over 200 graduate students, 60 faculty members, and 40 scientific and administrative staff. It caters to and supports research labs from engineering, science, agriculture, and many other colleges. The student body of Birck, called Nanotechnology Student Advisory Council, or NSAC for short, is very active in bringing a sense of belonging to all the students. Birck and NSAC together organize many outreach programs such as Nano Days, where we invite elementary and middle schoolers to on a 3-day extravaganza where they go through all the nanofabrication and nanotechnology oriented activities at Birck Nanotech Center, and they get involved and they learn about our activities. So such programs have made nanotechnology and STEM learning more and more accessible to the community. So with more such exciting opportunities, Birck is certainly one of the most lucrative places to work at. I've been here for more than 4 years. I've been working here in the field of microfluidics and micro and nanofluidics. And without further ado, I would invite Xiaohui to take you around the tour of this wonderful facility.
Hello everyone, my name is Xiaohui, and I'm a third-year PhD student working in Birck. So this is the entrance of Birck. So one of the most important science or technology going at Birck is the very extreme characterization techniques at Birck. So it's called nanotechnology, meaning that people are able to characterize materials at nanoscale. And just to show you one example how the characterization is done. So here we have the most fancy microscope to characterize the nanoscale materials. So just open the door for you. And you can see this huge microscope, which is just launched at Birck, I think last year for the characterization of nanomaterials. So another very useful tool is the atomic force or scanning probe microscope. You probably already have heard of it. So basically, we have a Lego demonstration station for that. And you can see that the way it works is that it has a very, I don't know if it's very clear, but from here, you can see that there's a very sharp tip so that it can just tap on the surface to feel the shape of the surface for the 3D reconstruction. And then here we have another gallery, and basically to your left-hand side here, they are all labs. And to the right-hand side, we have kitchen, and we have student offices. To the right-hand side, we have student offices, and they are always these transparent windows, as you can see. And in each of those offices, the students might not be from the same apartment, because here we have students from materials engineering, from mechanical engineering, from electrical engineering, and so on. So we have quite a number of different people working together. And this is the central hall here. So basically, to the right and to the left, it's just a symmetric setup. Basically, you have offices and labs in both hallways.
As Xiaowei climbs up, so a clean room, if people who don't know about it, clean room is quite literally a clean room. We can't allow anything that can disrupt our fabrication and our devices. Like Xiaowei said in the beginning, it's nanotechnology. We are dealing with things which we cannot even see with our naked eyes. We are dealing with things which are 1/10, 1/100th of our hair. So even if a hair falls off of your head, or a speck of dirt, or maybe dead skin falls off on your devices, they are done for. So we need to make these rooms very, very clean. So there are different categories of clean rooms: class 1, 2, 1, 10, 10,000, and so on. It basically means that number of ppm of the dirt, particulate matter, per cubic volume. So this is a class 1 clean room. And it's one of the largest facilities, as we said before, in an academic institution.
Right. So here, this is the front side of the clean room, as you can see. And so in order to make sure the inside is clean and not contaminated by the users, we have four steps shown here to dress up before entering. And you have to put on the shoe covers, and then you have the jumpsuit, you have your head covers, you have your mask, etc. More than half of the areas here classifies as the class 1, and this is the highest standard in the US.
The facility was designed in two parts, a clean room and laboratory areas. Clean room is the largest and cleanest university facility in the country. It's got about 25,000 square feet of ISO 3, 4, and 5 clean room area. ISO 3 used to be called Class 1. It's extremely clean. Cleanest hospital surgical rooms allow about 10,000 particles per cubic foot of air. In this facility, we only allow 1 particle. That makes up about 45% of a clean room. About 40% of a clean room is the old Class 10, ISO 4, and then the remaining areas, which are primarily aisle, about 15% of the room, aisle, tool cleaning area, things like that, are ISO Class 5 or the old Class 100. That makes us much cleaner than other university clean rooms in the country. Airflow is really the key to that. A normal house is set up with about 6 air changes per hour in your house. In our clean room, we're changing the air about 9 times per minute. So very tremendous airflow. Now this is really important. The airflow comes from the ceiling and flows down through the room. The problem you get into is that when you get into small particles, like a half micrometer particle, it falls in still air at a rate of about 2.5 feet per day. That really doesn't get the particles out of the air. So by having this air flowing downward all the time, it washes the particles through the clean room, through the perforated floor that we have, and then into the chases and back up into the air handler, where it's recirculated to provide even cleaner air on the next pass. So that sweeps any contaminants that are generated in the clean room out of the clean room.
Let's move on. So here we have a different color of window, which a machine called electron beam lithography. So this is a lithography machine used to create nano-sized structures on your material. So basically you can use the electron beam to treat your sample so that you can have like some fine structures drawn or created on your substrate. And this is very commonly used for people working with like nanostructured circuits or some electronic structures. And we have so this is an electron beam lithography. And we also have a similar machine called optical lithography. And the main difference is that the electron beam, the EBL used the electron beam as the source, while the optical lithography used the light as the source. Basically, the difference is just the resolution. And here we have some posters to introduce what is going on, like what technology is going on in Birck. And this is the station used to transport machines from outside to inside the clean room. So not only people have to be absolutely cleaned before you go inside the clean room, but also the machines used inside. So basically, if you want to ship anything inside, you need to first ship it to this intermediate room, and then let it stay there for overnight to be cleaned, and then you can ship it inside. And another thing, another interesting to mention is that inside the clean room, you also need special types of papers and pens, because the normal pencil or the normal pen we use will also create particles in the air or on your paper. So we have to buy special paper and special pens made for the clean rooms without generating particles. And a lot of people here actually are doing structures used for electronics, for silicon electronics or some other stuffs. And here, yeah, again, a yellow window. And this is just the photolithography thing I just mentioned. And the reason it's said to be yellow is that, so basically you need some UV light for the sample treatment to get those fine structures. And you don't want your sample to expose to this UV light other than that treatment time. So you have to filter out the UV light from the natural light. So that's why the light inside the room is yellow, because the UV light is filtered out. And we have quite a number of photolithography or some electronics clean room lab here. And so basically here we have different levels of clean room. Where I just showed the electron beam lithography there, that's the class 1. But we also have some class 2 or not class 2, lower classes of clean rooms for those experiments or those work that doesn't require very high clean room levels. And again, we have some metal film deposition machines as shown here. And if some of you know, there are physical vapor deposition or chemical vapor deposition, etc. Different deposition techniques. So here is a kind of a separate, smaller clean room. As I mentioned, it's like a lower level clean room for some electrical characterization, which can be lower level. So you can just enter from here and wear your lab coat from here. And this is quite like a very large clean room. And you have like instructional laboratory. Another thing I'd like to mention is that, so we not only have students working inside the clean room, we also have some industrial partners. So basically people from the industries, they can just reserve some offices or some seats here and then stay here for a long time to conduct their experiments using our clean rooms. And now we are close to the end of the clean room here. We have here a dilution refrigerator, which is, as you can see, so basically it's a huge refrigerator used to create a temperature at 0.01 Kelvin, which is very, very low because room temperature is still around 300 Kelvin, right? So by going to a very, very low temperature, you will be able to like do some specific research experiments, and that's created for that. And we also do different types of sensors. By the way, I'm working on some optics, like some optical materials, photonics, that field. So I also work a lot in the clean room to do some like sample preparation, electron beam lithography, and so on.
That's what I do in my lab. We manipulate fluids using light. So part of optics, part of fluids. We literally shine a laser dot, like a laser pointer, and the water droplet just chases the laser pointer around it, just like a cat. So that's what it is. So we can manipulate water droplets on our will. So yeah, that's one of our labs.
Cool. That's cool. Is that inside the clean room?
So the clean room, we use, just like you, fabrication of our chips in clean room, but the rest of the characterization is done outside in our lab.
So yeah, we have a very small window here, which is used to like a small elevator, I think. So it's used to ship or transport samples or some other things from outside to the inside of the clean room. And I think here, this is the bio clean room side. So basically, this is the entrance of the bio clean room. And as you can see, they also have their own entrance here with the lab coats, everything inside.
That thing is called roll-to-roll fabrication or roll-to-roll manufacturing. So just like a newspaper print, we have rolls of big films and we can bulk produce any of our devices on the go, on the fly. So that's used to mass produce the devices, especially thin film based devices.
We also have a Microsoft Q station here.
Yeah, they have a big station for quantum computing as well. So that's what they do there at the Q station, right. Microsoft.
So yes, that's a very good point, because Birck is now going to quantum pretty fast, and I think it's just last week Birck joined the 3rd quantum science in the US, and Birck actually, Purdue is leading one of the projects for the quantum computing. I think it's this one.
Yeah.
This is just one of them, but I think they have a few of them here.
Yes. So you see that huge transformers-like looking thingy? That's used to create ultra clean and ultra epitaxy substrates, and it's used for fabricating devices for quantum computing. So this room is actually connected by 2 other rooms, and they have connections of both air handling and electrical connections through the walls. So if you go on the left, you will find another lab with a similar machine which is connected to this machine.
So here, I'm going to the left. Yeah, that's right. So we have a similar here.
Yep.